So let's do a quick code walkthrough of TK8. What we'll be doing here is we'll be doing an execution flow of the whole code base on like how a particular functionality is implemented, where to go and look for that particular function, for that particular options, and the overall the overall data walkthrough of the whole repository. So the first thing that we'll have to do is we'll have to clone the repository from GitHub. Now, one thing to notice over here is that Go is very strict and picky about how we organize our projects in the Go root. So one thing that we'll have to take care of is that in our Go root, so there will be this variable that you'll have to set for Go, where you'll define that, okay, in which particular location your Go files and packages and source code will live. So in that in your Go root, you'll have a particular folder called src. Inside the src, since we will be importing a lot of Go packages from GitHub, so we will be having a github.com folder. So ideally, inside the github.com folder, we will clone the repository in a folder called Kubernauts.IO. Now I already have this particular folder cloned on my machine since I've been working on the TK8 repository for the last few weeks, but in case if you're starting fresh and new, then go ahead and you'll have to like respectively create the folder. One way on which how you can actually like automatically create this particular folder is to pass the just give me a sec to pass the respective folder location that you want as a second argument at the time when you're cloning. So let's say we are cloning the TK8 repository from TK8, then we simply will do, that's copied, and then we simply will go /TK8, and that way Git will automatically will create those respective folders and will clone the repository in that particular child folder that you have mentioned. So now if you see, we have a Kubernetes folder created. We can go in the Kubernetes, and we'll see inside Kubernetes we have another folder called TK8, and inside TK8 we'll have all of our files as in the repository. I don't think so. Okay. Now, yeah, we definitely can clone this particular clone the Kubernetes. We definitely can clone the TK repository in anywhere else, like in directly your src folder in a folder called TK8 if you want. But one issue that I faced due to that is since we have the CMD folder of the TK8 repository, this folder of the TK8 repository as one of the packages that we import in our project. So because of that, if you actually clone it somewhere else and make any particular changes, you'll have problems. So that being said, now one thing that you may have noticed here is that we directly cloned the repository from Kubernetes. Ideally, you won't be doing that because you'll be forking the repository and you'll be working on your respective fork, right? So one easy and nice way to do and deal with it is you can clone your repository at the specified location, that's Kubernetes /TK8, and then you can have two remote branches to your repository. So if I show you here, I have two branches. Origin specifies my upstream, that's my fork of the TK8, and upstream basically specifies the Kubernauts TK8, so that if we have like in the time when we are actually working on our particular fork, and in meanwhile if there's some particular changes that go and that has been merged to TK8 in the Kubernauts TK8, and we want the same like we want to get in sync with those changes and get in sync with the master repository, all that we can do. So all we can need to do is simply do a git fetch on the upstream master, and then check out to upstream master. So that way it will pull all the changes from the Kubernauts TK8, and it will merge all those changes, or rather it will add all those changes to our local repository. Once that's done, all then we will need to do is simply a rebase of the repository, and we'll be all in good shape to go ahead. So let's now dive into the code base itself. So once you start the repository, sorry, it took a little time. So once you start the repository, the files that you will be noticing is there is so the chapter1.md is basically for the Gitbook documentation of the whole project. Config.yaml actually contains the configurations that you will be needing to create an AWS cluster through TK8. The debug file is like my local file that I use for debugging purpose. The Docker file is the Docker file that's like it's currently, this Docker file hasn't been merged to the original repository, but once it's merged, this Docker file will be the particular file that will be used to create the official TK8 Docker images. And now the go package.lock and go package.toml is basically the files added by dep for the dependency management. So all of your packages that your project uses is actually specified in go package.toml and go package.lock. So basically lock actually specifies a particular specific version of the packages that you're importing in your project with the respective commit SHA. And go package.toml just like specifies okay which package, which version you're using. So like if you're doing a fresh clone of the repository, the first thing that you should do is the ensure -v is for verbose. I like to use it with -v flag, because then it shows like all of the Git tree that it traverses, and for fetching all of my packages and all. And I like to see like what's the behind the scene progress or things that my tool, my CLI is doing. So yeah, you can if you don't like all those details and all, you can use dep ensure without the -v flag, but I like my ensure with verbose flag. So in case if you want to check if a particular dependency has been updated, like if there is a new version to any particular package dependency that you're using or not, you simply can use the update flag again. Since I have made some changes to the like few of the files, I'm really skeptical of like whether or not should I do a dep ensure or dep ensure update, because like it can override those changes. Okay, let's try. Let's see. So we'll simply first we'll do a dep ensure v, dep ensure -v to ensure that okay, we have all the packages. And once it's done, it's about 15 packages that it actually imports. So once it's done, then I don't know, maybe we'll do a dep ensure -update. One thing that I'm actually now thinking is like maybe dep ensure -v won't override my changes, but could be that dep ensure or -update can override my changes, because again, the whole purpose of ensure update is to see if the package that we have locally aren't they outdated or not. So yeah, let's see if it does override my changes or not. Okay, so it like the very first okay, so give the warning over here. Warning: the following projects have constraints stanza and not direct dependency of the current project. They are not imported in any of the Go file, nor they are on the required list of Go terminal dep only apply constraint rules to direct dependency. So these rules are import required packages. Okay, so one thing that I'm actually now noticing is yeah, it won't, or it rather didn't update it or did any changes to my existing files, is because so deb actually looks if we have that particular package already available in the our respective folder location or not. And since our project folder itself is Kubernetes TK8, so it, I guess because of that, it doesn't actually do any change to that. Now it does say that okay, it's not imported in any of the Go files, which actually is wrong. So now that we have did go sorry, now we have since we have ensured that okay, we have all the packages needed, what we can do is or rather what we can do is to ensure that okay, we have a working repository and the working clone of the repository. We simply can try first by okay, let me first uh, remove the binary that I already have. Okay, and yeah, let's do an ls. So as you can see, there's no pre-built binary over here, so what we can do is build, sorry, TK8. So what now Go will do is it will go ahead and compile all of our Go code, and we'll create the respective binary out of it. So now you can see that we have the binary, and we can do TK8 cluster. No, let's just do TK8. Yeah, it seems working now. Again, there's only one very teeny tiny change that I have done, is to add check for the git binary. Sorry if I pronounced that wrong. Yeah, it felt weird. Anyway, so the check that I have simply added is to ensure that we have git binary installed in our machine, or rather it's available in our path variable, so that when TK8 actually tries to clone kubespray, it doesn't throw an error. Earlier I had this issue where I tried to do a TK8 cluster in it, and it simply threw, okay, there's something problem. And then I realized, okay, I don't have git, so it won't be able to clone. And then I was like, okay, we should have a binary check. Anyway, so that being done, let's simply walk through the code. So issues is again the a local file that I'm maintaining on things that I'm finding that should be in the CLI, but it's not currently present. So I'm just like creating a comprehensive list of things, like future to-dos for the TK8. So the very first thing, so the very first file that actually is of our interest here is main.go, and the main.go is basically what define what or where you define your main package. Now, the main package, as in any programming languages, will be the package that actually is responsible for the start of the execution flow. So the main package is where you'll define your main function, and it's here from where uh, all of your code will start to get in execution. So as you can see, we have a very teeny tiny small main package specified. So again, the first line just specifies, okay, which package this particular file will be a part of. Since this is main.go, so it will be a part of the main package. And apart from that, then it specifies that, okay, this particular file will be importing this a particular package that's available at github.com/kubernots/tk8/cmd. So basically, this particular file will be importing a package from this particular folder. Now, since we have our repository cloned at exactly this location, so whatever local changes that we will be making, like, it directly will be reflected in our code. Uh, so the mistake I did previously was I cloned it in my own at my own specified path. So Arush -sal/tk8, and then I was trying to make the changes, and the changes won't reflect. I tried almost every crazy combination of things to reflect these particular changes, because again, I didn't have like gone through the main file. Or rather, I had gone through the main file. I just saw the main function 3 lines long, and I was like, okay, everything is in the CMD folder, so let's not bother ourselves with the main file much. And then, like, after a few hours of troubleshooting and head scratching and hair pulling, I've basically figured out, okay, since we are importing the CMD folder in our main file itself, that's because of which whatever file it's actually using for its compilation and all is from the Kubernauts/tk8 location. So it's actually from the upstream, not my local version. So one more thing, as you can see, this vendor folder is where all of your local dependencies will go. So all of the packages that we have imported and the packages that those packages have imported will be stored in this particular vendor folder under GitHub. Again, since it's from GitHub, so it will be stored under GitHub. Similarly, the Golang packages, that's external Golang packages that we'll be importing, will be under Golang, under X, then the package name, and similarly the gopackage.in will store the packages it's actually using from the gopackage.in. So if we talk about the main function, our main function just specifies one single line of execution, and that's cmd.execute. So what that basically means is, if we go in the cmd folder, right, you can see the root.go. Now, root.go is the file that's responsible for the CLI's root functionality. That's basically the base functionality of the CLI. So as you can see, the first line specifies that, okay, now this particular file is part of the CMD package, and any reference to any of these any of the function mentioned in this particular file will be through the package CMD. So you'll so as we saw it earlier, the single line of execution that we had in main.go was cmd.execute. So this execute function is defined in the root.go. So you see, as you can see, like, the execute function, what it simply does is it checks if the root command.execute produces any error, and if the error is not equals to nil, that's is if the error is not empty, then simply print the error and do an exit. So okay, next thing that we need to check is, okay, what's this root.cmd. So if we just keep our mouse there for about 2 seconds, yeah, it shows it shows us a brief overview of okay, what the root command is. And the root command is basically as specified in the Cobra package by SPF13. Everyone knows Cobra, the most awesome CLI package. Okay, so as now you can see that, okay, sorry, what the root command does is it actually it's actually just storing the pointer for the cobra.command function. Once the execute function is triggered on root command, it runs the init function of the Cobra as defined in the Cobra package. Now, the very first thing that the init function does is it triggers the on initialize function from the Cobra package, and it passes the init config function as an argument to that function. Now, what that does is it checks if the variable configuration file is not empty. It sets the configuration, it sets the path of the configuration file in the for the Viper package, and if if the configuration file is actually empty, then basically what it does is it, using the home dir package, it finds the home directory of the user currently running the CLI, and then it simply creates a .tk8 folder in the home directory of the user, where all of the configuration file will be stored for that particular user. Now, then it goes ahead, reads all the environment variables, and then it checks if there's already a configuration file present in the user's TK8 and .tk8 folder in the home folder. If it's available, then the available file is used, and in case if it's not available, then creates a new one. So this is where the execution stays till if the CLI is called without any arguments or without any commands. In case so the available commands for the CLI are well, let's do this. So if we do just TK8 so let's go install TK8. So if we do just TK8, the root.go is the file that's actually responsible for this for printing this help message and for all this execution. Now, as you can see, there are actually 3 commands that are available. Now, the moment we start to use any of these particular command, other files that we have in the CMD folder comes in action. And for example, if we do cluster init, the init.go is the file that's actually responsible for taking care of the cluster init the cluster init command. Now, one thing that we actually should add is somewhere here we should add that, okay, the global flag can also be given, so it rather should be, okay, config that, and then command, and then flags, right? Like the proper usage help should have been that like this, but again, it's okay. It's cool. So yeah, now the very first thing that this does is it simply adds, like it simply in its init function, it simply passes the init cmd init command function to the add command function, which basically then tells the whole Cobra package that okay, a new command is to be added to this particular command, this particular subcommand. So, like the moment we do TK8 cluster, this is the file that gets executed, right? So again, it specifies as part of the package CMD specifies that okay, we'll be using the OS package and the SPF13 Cobra package, and then in the init function it specifies that okay, in the root command, which basically was defined in the root.go, simply add a command. That's the cluster command, whatever is defined in the cluster command. So as you can see in the cluster command, the usage specifies as cluster, that okay, it will be used as the name cluster. Its usage is to create cluster on cloud infrastructures, right? So if yep, this thing on cloud infrastructure. So yeah, that's where the short description go, and like if we do TK8 cluster help, this line is coming from the long description that's basically here, right? So then what it simply does is it checks for the arguments, and then it passes like it defines its execution flow, or how it will be how it will run. So by default it defines that okay, no, there's no arguments, and then in the run part is actually specified that okay, pass the pointer of the Cobra command, this particular command, as cmd, and with the respective arguments, and then if the length of argument is equals to 0, then print help, and then simply exit. One thing that I missed here is if you go back to the init config, yes, this thing, the root command, you see this basically specifies okay, what will be the name of the binary, like by which name our binary file will be executed. So okay, once that's done, then like depending upon now what sub command that you execute, it goes ahead and uses one of these files. So if in case if you do cluster init, this is where our execution flow comes in, and again follows the very same pattern, defines the packages part of, defines which all packages that it will be using, and then uses the init function to define to simply initializes the particular command, and like what command to run. So in this case, as you can see, it's actually running and the init cmd command. So here's the init cmd command. It will be used as init. The short usage, which we can see here, is this. If we do init, we can see the long usage, which basically is clone the kubesphere repository in GitHub. No, it should be from GitHub. Let me change that. From GitHub should be GitHub. right? Now here's the cool thing. Now I can do, let me, you see, instant change. Now if it would have been an Arush-Salil/TK8, it would have taken like these code files from the Kubernauts/TK8 and this couldn't have reflected here. So yeah, I feel pretty smart about knowing that, but yeah, that's something pretty obvious to know. Okay, that's that. Then it defines its functionality in the run section. That's basically that, okay, whenever this particular function is executed, first thing to do is print that initializing kubespray get repo. So okay, let's do this thing. Let's do slash and then kubespray. Right, and then do TK8. So one thing that I was actually planning earlier was to actually do this whole walkthrough using a debugger, but as it turns out that my debugger skills or debugging skills isn't of any use. Basically, I just don't know how to. So yeah, I decided to do a plain code walkthrough rather. So yeah, let's simply use that command. So TK8 cluster init. What it does is prints this particular line, and then if it goes ahead and check if there's already a kubespray folder available in the current directory or not. Now using I'm personally against using relative path, because relative paths is totally relative to your current folder, current context, which is not a very um, it's not a very foolproof way of getting the repository. So rather of that, instead of doing a relative path, we rather should do absolute path. But again, I can be wrong on that. So yeah, and the very first thing it does is actually we check if there is kubespray folder already available in your current directory or not. If it's available, it simply will print this particular message and exit. If it's not, if the kubespray directory is not available in your current folder, then what it does is basically goes check for the git binary, and if and the look path basically returns two variables: the location at which it found git, and if there's if there has been any error. So since we really don't care about location, we simply discard the location, then we simply is recording the error. Now one thing again is we rather instead of just using git, we rather should be using the absolute location that we get from here. That again, better way. I feel that's the better way of doing this, because again, relative paths could be pretty challenging, pretty tricky, pretty nasty. So instead of doing git, we rather should be using the absolute path that we get from here. But okay, in case if there's no, in case if there's an error, that error is not equal to null, it simply will log as fatal. Basically, log or fatal specifies that okay, there's something very horrific has happened. You should immediately look about it, and so it will print that particular message as a stack trace. Not exactly a stack trace, but a stack message or an error message instead of just an message, as in case of println. So yeah, it goes ahead and prints this particular message, and then does an OS exit with exit status 1, which basically is for file not found. In case if the error is not is actually nil, then it goes ahead and executes this particular command, which is git clone this particular repository. Then the run function on the command is I'm missing what it's exactly called. But okay, it's basically it specifies that okay, whatever argument has been given to this particular command function, run that particular commands in a shell. So it goes ahead, runs the git clone command, and if in case it records any error, there's an error check that okay, if error is not equals to nil, that's it. It has recorded some error, then again log fatal, and then tell the user that okay, there's might have been some issue, print the error, and then do an OS exit. As we can see that like we just got initializing kubespray git repo because I have git installed. My folder didn't had the kubespray directory already. So if we again try to do this, you see kubespray clone on this machine already exists. So that's basically is because it failed this first check and this happened. So if we try to do this, no. So instead of this, let's try the TK8. Yeah, the bash auto completion. Right, so now if we try to do the TK8 cluster init, I don't like say since in our Docker file we have a multi-stage build, so it basically comes with two stages. The first stage is called builder, and the second stage is basically TK8, the TK8 stage. So what I've done is I've created both the images, and Git is not installed in the builder stage or the builder image, because like earlier it was, because we needed that because we were doing an dep ensure every time we were running we were building that particular image. But now since we are including the vendor folder itself in the repository, so that's why we don't need to do a dep ensure every time we build our images, which basically speeds up the whole Docker image building process by like so much, I can't tell you. So that's why we don't need Git or anything else in the builder image, and very good way to test this check. Anyway, so yeah, that's about this. So like if we then go ahead and do TK8 cluster AWS, then it basically what it does is it goes ahead and it triggers the command from the aws.go file, and again very similar flow as we have seen here. So the file may look pretty big and daunting, but it's pretty small. It's pretty easy and understandable. So again, what it basically does is cluster.cmd. It simply like as its init function, it passes the function that it needs to trigger whenever this particular command is executed, which is over here. And then what it basically does is it specifies 3 flags that can be passed to this particular command. Now those flags are again of Boolean type, as you can see. It says boolvar, boolvar, which basically is Boolean variable. And what it does is it actually passes the pointer of those respective variables to the function as an argument, and those particular variables as Boolean type has been specified up here. Apart from that, it actually specifies 2 things. They're short and long format, so like the single hyphen and the double hyphen format, and their default value and the different description. So like once that's happened, like this is similar command definition that we have been following till now. It like defines the usage name and then the short description and the long description to use, then any default argument, which basically are not default argument, but yeah, like what will be the default arguments, which basically is no argument. Then it defines its actual executions. So if we have passed the install flag, that's -i or -install, as you can see here, what it will go ahead and then like it will check if Ansible is installed. Now this is pretty interesting. It looks for Ansible, but it stores the location in TERR, which should be used for, which has been used for Terraform. It stores the absolute path in a variable that should have been used for Terraform. So, Ansible. Okay, camel case declared but not used. Yeah, used but not declared. Okay. Then yep, it goes ahead, checks for Ansible version, stores the output of the version in the RR variable, does an error check and prints the version. Then Kubernetes installation starts, check if Ansible host file exists, checks for the host file. Now, I'm pretty sure the Terraform issues that we are seeing is because of using the relative path instead of absolute path. And like this is the point where we will need to start in case if we want to fix that bug. So yep, like it checks for the host file, does an error check, then checks for the configuration, like the configuration file, does an error check, creates a bunch of directories, takes the uses the K8 cluster YAML file available in the inventory folder, AWS cluster folder of KubeSpray, and then goes ahead, does the KubeSpray installation. Right, so that was about install. Similarly, if we do destroy, now here it's actually doing Terraform lookup, so that's cool. So yep, if it's a destroy, it actually tells Terraform which Terraform state file to use, and then simply does Terraform destroy. Now again, here it actually checked if credential file exists. Now a few things that was a big time deal breaker for me here in this one is like it needs to it need me to specify my secret key and access key in the config.yaml. Yeah, over here. Now big time against of it. I do not like or will ever specify my access key and secret keys anywhere in plain text in a file that is stored on disk in plain text. So yeah, that's a big time deal breaker for me. So we need to fix something, do something about that, like in case we don't find, and like if that wasn't enough, then all those access key, secret key details are then stored in this credentials.tf4. I'm pretty sure no, that's stack credentials. Yeah, I don't think so. Nope. Yeah, for my test purposes, I directly did it in the container. I think I've removed that container. But again, that's a big time deal breaker for me. I mean, and should be for anyone who has security in mind. Like you don't want your access keys and secret keys just lying around on rest in plain text on your desk. So yeah, in case if that's like it doesn't find the credentials file, then it goes ahead, asks for access key, secret key, SSH key name, AWS default region. So there are a few things that we need to add support for, is things like reading from a specified file, like these details from a specified file, so that the access key and secret key can be you know, mounted in the container as a Docker secret or Kubernetes secret. Uh, if not that, then we need to add support for reading this uh, variables and these values from environment variables. Again, big time no, but still better than storing like those things in a config.yaml. Yeah, from environment variables, then dot AWS slash. Then we need to like add support for reading these informations from uh, users home folder dot AWS slash credential and config, and need to allow user to like even specify like which AWS credential and config file we should use in case if the user have those in some other folder, or like is on the same machine some other user have it, and that user wants to use that particular files. Apart from these two, we need to add support for instance profile. Big time winner, at least for me. Like attach instance profile to the machine, especially if you're doing it directly from AWS. Simply attach the IAM instance profile to your instance, and you forget about everything else. So yeah, we need to add support for that. And last thing is cross control. Yes, that would be like the biggest tricky and challenging, but yeah, we should add support for cross control. And yeah, apart from that, we should document like the least privileges that we need. Like, okay, when I was doing the AWS test, I was like, okay, what all privileges do I need to get this thing running? And yeah, obviously I knew that, okay, since it's using Terraform under the hood, so yeah, I most probably can go to the Terraform documentation, get that information from there. But again, I wasn't really sure, okay, on what all resources that it will be creating, and like if the IAM permissions and policies mentioned in the Terraform documentation will be more than enough for it. So like I had to go ahead and provide it administrator access, which is certainly not the way anyone else would like to do it. So yeah, anyways, so it asks for all these permissions, then it creates the credentials.tf4, then goes ahead and what? Okay, you know, add all of this, like all like then it creates the file here, adds all the value in the file here, and then closes the file. Yeah, using defer. Now that being said, like using defer on a like in a write operation on a file is something that should be refrained. Let me see. Don't use defer. If I can find defer using from use different code. Okay, there was a file. Defer colon. There was a don't defer close on writable file. Yes, this thing. Like it's a very amazing post. Describes like why we shouldn't, and like how file buffers and like IO buffers happens, and like how all those things can mess up with the file, and our our expectation for the file, and for the data, how it can create inconsistencies and things like that. So yeah, it's a big tricky thing. Like, there's not a rule that okay, you know, a plain old and hard rule you should never use like close on like in defer on files, but yeah, need to take care of that. So again, okay, then it like simply goes ahead and sets the terraform destroy command. Now why we are using force, okay, I'm not very sure about, need to check with Christopher for that. Then it sets okay which is the relative directory that we should be using for this particular command, and then we simply like store the standard output pipe for this particular command and standard output, standard error. Okay, and then we simply like map the standard error also to standard output, and then we simply trigger the command and check if there is some error, then print the error, and then goes ahead and we start printing the standard output from that particular command, and then it does a wait to ensure that okay, Terraform has exited properly with zero status and things like that, and then does exit 0 on Terraform. Similarly, we have create. Again, there's like almost same thing as destroy, with just a simple difference. I am really not sure why we are not asking for the credential files here. No, we are. Sorry about that. So yeah, I guess we are asking for the credentials here. And then yeah, we simply check for the file. Not if it not exists, we create the file, ask for the credentials, store it in the file, and write the file. Then we remove the terraform.tf4. What file is that? I really will have to check. And then we like read in a lot of input from the config file, like this config.yaml file, like all these different type of errors. Sorry, all these different type of values from the config file, and then like we simply go ahead create a terraform. So since we will be creating our own new terraform tf4 file, we simply go ahead and delete the previous one. Okay, cool. So that happens, and then I think we should remove these, and then like bunch of other stuff. Simply we like similarly we go ahead and set all the parameters, set the command, connect the standard output, standard error, and then connect the Terraform's output to our screens buffer.io output, and then voila, go ahead. So that was AWS. Similarly, OpenStack.go like again specifies the command, and okay, again it specifies 3 flags, specifies the command, does it like so very similarly it describes a terraform destroy, terraform create, and Kubernetes install for OpenStack. Then for bare metal it specifies load balancer, destroy, and install. Now here's the interesting thing. If the load balancer can be false, right, then why if I try to do a bare install, it like specifically asks me that okay, you haven't specified the load balancer. No, sorry, it's actually in here, OpenStack here. So if I remember cluster.tf4, if if I go in here and I have, yeah, so if the load balancer can be false, which by default it is, then why it forces me, and so Control D, Arush, okay, local. Right, so if we do TK8 OpenStack, okay, TK8 cluster init. Sorry, interesting thing. Now, another thing is now another thing is that okay, because of because where's that OpenStack function? Yes, no, because it's expecting everything in terms of relative paths, so it won't really work if I try to trigger it from anywhere else. So you see if like it does a relative path. So because of that, we'll have to always do it from the TK folder, which is a big time bummer and big time no. So yeah, relative paths are evil. Yeah, don't quote me on that. Cluster. Create. Right. Credential file. Please check on this. Okay. Whoa. Oops. Shit. CD. Yeah. Okay. Now this is a big time bummer. It's good, but again, if I clone my kubespray directory in some other folder, like let's say temp folder, and I want to do all of my operations from that particular folder, like whatever folder, my home directory, my downloads directory in my home directory, my documents directory in my home directory, or any other folder. Now, kubespray will be cloned relative to my present working directory, but everything else, it needs to be in the TK8 folder, which is like a big time devil dependency, I'll call it. Okay, so TK8 cluster OpenStack. Okay, so let's do this. Create. Oops. Okay. Oh, my bad. I'm so sorry. I was doing it in bare metal. Oh, oh, yes. So sorry. I got confused. But yeah, the OpenStack one was correct. Yep. Yep. Sorry, I got confused between OpenStack and bare metal. But yep. Okay, so it specifies 3 flags, and then simply goes ahead and deploy the cube config. And then like accordingly it simply goes ahead, specifies all the commands, and like how those commands would be done. Now okay, Ansible, that's Ansible, and then Ansible that. This seems to be pretty cool. Know that okay, it won't throw any error because I have my vet. Yeah, I have go vet configured on every save, so yeah, it's all good. So yeah, like similarly, it simply goes ahead and it's like pretty straight and simple, like how we used to do in case of a shell script, like creating a command line tool in shell script. We used to have a case like defined, a switch case defined, and then we simply used to do string matching in the case, and then based on the string match, we used to perform some operations. It's it's like similarly, it's what being done here. And yeah, that's pretty straightforward. I've not used add-on till now, since but yeah, it seems pretty lengthy, and it seems okay. I'll do load testing us. Okay, so we have JMeter, we have Prometheus, and then we have Heapster, and if we go above, and then whoa, like similarly, we have the definition for all three. So okay, so what it does is present the paths of your kube config. So now again, it should like by default make an assumption that okay, the kube config is in the user's home folder. That being said, now it was init.go, right, where we had the home folder. No, it was root.go. So um, um, yeah, ideally, right, ideally, right, the home folder is always so if we go and if we do home, yep, I ideally always have oops, we ideally always have a environment variable called home in each terminal, right? If not in the environment, like so, what we basically can do is we can check for the environment variable home. If not, then we simply can use the tilde, yeah, the tilde symbol to dereference the path for home folder, which basically will remove one of the dependency from our code. So yeah, like that's something that we should think about, and we should take care of. Um, so yeah, few simple pointers, my 2 cents. Okay, so yeah, first thing, like we should actually assume that okay, it's in the user's home folder cube .cube folder called config, and so please enter the path to your kube config not found. Oh yeah, and then kubectl is installed. Kubectl currently check. Okay, again, right, it's okay. This is one thing, or like kindly check, or instead of kindly check, how about if we prompt the user that okay, do you want us to install kubectl for you, or like no, it makes sense that since kubectl is not installed, like, so we should first check for kubectl and then we should check for kubeconfig, because if there is no kubectl, there won't be any kubeconfig. So the very first requirement is actually kubectl. But that being said, that's very assumptions of me. Like somebody can not have kubectl, but they can like download or import kubeconfig from one of their friend. But again, on kubectl, like if it's not available, we simply can print okay, kubectl not found, downloading, and then we can prompt okay, this like we're gonna download it from this particular location, do these particular things, like move it to your /user/local/bin, do a chmod on that. So like if you're comfortable with that, proceed yes, like press yes. Why? So yeah, and then start again. What if there isn't Git? I mean, to be very honest, I'm pretty sure this error check is with the has been done with the idea of that, okay, if there's not Git, it will throw an error and things like that. But what if there is Git and you know, the cloning just was not possible, or the cloning broke because of some network issue, like huge network latencies, slow speed, timeouts, anything. How are we supposed to like differentiate between okay by because of which reason it's happened? I mean, I'm pretty sure that including the error message as part of the including the error as part of the error message is like been done with the same intent, but I personally believe that we should rather check for existence of Git before we actually go ahead and do that. So yeah. It is good, but again, set and and to be honest, guys, instead of like my impression of this whole is more of like a big shell script written in Go rather than a Go code itself. It feels like if every here and there, all it feels is exec command. If all we are planning to do is exec command and do our thing, is then like we are better off with shell scripts rather than writing all of this in Go, because again, kubectl, Terraform, those tools themselves are in Go, and what's the point of like again, I believe in and think that could be wrong. I'm not a software engineer, I'm not a developer, not a programmer, so could be big time wrong. But yeah, that's how I believe. Like, what's the point of doing something in a full-fledged high-level programming language if you're not 100% utilizing its packages and libraries and all that? Like, if all we are doing is exec commands, then we simply could have gone ahead, done each and every thing that we are doing in all of this, in this whole CLI through shell scripts. Yeah, that's like, I believe that's something that we should think about, take care of. Then yeah, it's like yeah, it simply goes ahead, asks user for a bunch of stuffs, and then installs like this. So yeah, I guess that's basically it. All of the commands that we have, the overall walkthrough of the code. Let me know. Yeah, I know I did a lot of blabbering. I did a lot of blabbering, nonsense, and all of that. But yeah. Let me know what you think about my opinions. How you think, like, how you feel about that? What do you think about them? And yeah, was this any helpful or not? Adios.